ladies and gentlemen, so today we're starting chapter 7, which is hopefully going to be a little bit easier than some of the stuff that we worked on. It's still related to functions, but now we're going to focus that into geometry. And we're going to actually start off and do a little bit of review of some stuff we ended with in 7th grade last year. So we're going to start today talking about volume. And volume is the amount of space, and I'm abbreviating amount, inside a three-dimensional figure. Okay, so it's inside a three-dimensional figure. A rectangular prism is what we're going to focus on today, and a rectangular prism means that the base is a rectangle, and it has and it has rectangular sides. And okay, so we have a formula that we use, and our formula is really like a function. All right, it's not necessarily going to be linear, but it's going to be a function because the volume is a function of what the sides are. Remember, function means it depends on. So our formula that we use, capital V for volume, and again, hopefully you remember this. And I know most of you do, because anytime I ask for a formula, you want to tell me this one. Volume equals LWH, where L is the length, W is the width, and H is the height. Okay, so let's see. So you're definitely going to need your calculators for this. And again, we're going to show, we talked about this last year, we're going to show 4 things: formula, number, answers, label. All right, that's what we're going to show. So here we're going to start off pretty simple. Everything is in feet. That's one thing you want to double check to make sure that you have all the same unit. If not, you have to change them so that they are all of the same unit. We're going to start with our formula. V equals LWH. We're going to take out LW and H, and we're going to fill in my numbers. Doesn't matter which one you call which. So we're going to have 4 times 7 times 10, which is 280. And our label is always cubed for volume, feet cubed. Okay, for number 2, we have another rectangular prism. So my formula, LWH, fill in my numbers, 8 times 3 times 4, which when I put that into my calculator, hopefully, I am going to get 96 millimeters cubed. Again, this is a review from last year. All right, now we're also going to kind of take it a little bit up, take it a step up, and now we're going to say, okay, can I use this idea of an equation, a formula, a function to solve for other things? So now they tell me the volume is 61.6 inches cubed. We want to know the height. We don't know what the height is. We do know the length and the width. So, still starting with my formula. V equals LWH. I'm going to fill in what I know. This is your V, 61.6. This is your L. This is your W. If you reverse those, that's okay. And we have to get H. So I'm basically trying to figure out what H is. I'm solving my equation for H. Well, in order to do that, I'm going to do 8 times 2.2 first, which is 17.6. Well, how do I finish getting H by itself? We spent a lot of time solving equations. So now I have to take and divide both sides by 17.6 to figure out what H is going to be. Gives me 3.5, and my label is just inches, not inches cubed because I didn't find volume. Right? When we're measuring a distance, it's always just a plain label. Okay. Find the value of the ratio that compares the volume of the larger prism to the smaller prism. So if we go back and talk about what we talked about with dilations way back when, right, this is a dilation. We're taking this box and we're shrinking it. We're making it smaller. And I'm asking you, well, what is it that I am shrinking? How much am I shrinking it by? So I'm going to do the larger one. I'm going to actually do it over here. LWH. So we have 5, 7, and 9. So 5 times 7 times 9 gives me 315 centimeters cubed. The volume of the smaller is 3 times 2 times 3 times 2 times 4.5. Again, I'm using my calculator. This is considered showing your work when you show me your formula, your numbers, your answer, and your label. All right, so let's see. It says that compares the volume of the larger to the volume of the smaller. So we want larger on top, 315 over 27. So I'm going to see if that can reduce. Oh, let's see. If I put that into my calculator as a fraction, right, we're going to kind of do a little bit of fancy work here. So I'm going to put it in as a fraction using my ABC button. When I hit equals, it turns it into a mixed number, but I want that to be a improper fraction, so it's 35 over 3. I basically ended up dividing both of these by 9. But again, if you put it in your calculator and it gives you a mixed number, you can change that mixed number into an improper fraction, either with the calculator or by yourself. So the ratio is 35 to 3. Okay, that's what that is. 35 of this is equal to 3 of that, is what it's telling me. Okay. Oh, let's see. I tried to change the numbers on this and it wouldn't let me, but we'll see what's happening here. So as you complete exercises 7 through 10, record the information in the table below. Note that the base refers to the bottom of the prism. All right. Now my area of the base, when we're rectangles, the area is length times width. So let's see if we can look at it here. Use the figure at the right to answer the questions. What is the area of the base? Well, A equals LW, and that would be the bottom, which is going to be 12 times 3. Which would give me 36 centimeters squared. So area of the base, 36 centimeters squared. My height is 3. So what is the volume? 36 times 3. Because we already did our LW. 108 centimeters cubed. So we're kind of doing the work down here, but we're recording our answers in the chart. Number 8, area of the base. So again, the base is the bottom. So area is 12 times 3, which is 36. I'm going to record it up here. Oh, look it, we have the same base. All right, now let's see. What is the height of the figure? The height of the figure is 8. What is the volume? Base, area of the base times the height, which will give me 288 centimeters cubed. So I'm going to go back up here, fill that in. This was 8 and 288. Okay, what I would like you guys to do, try it on your own, and then we'll come back and you can check your answers. I want you to try 9 and 10. Same thing that we just did. What's the area of the base? What's the height? What's the volume? All right, so I'm going to do those, then you can come back and check your answers. All right, guys, let's see how you did here. So you should have gotten for A, 36. I forgot my label, centimeters squared. My height was 15, and then my volume was 540 centimeters squared. For 10, my area is still 36 centimeters squared. This time, though, they gave me a height of x. So there's another variable here. We didn't know what that was. Then it says, write and describe a function that will allow you to determine the volume of any rectangular prism that has an area base of 36. So here's my formula, volume equals 36x. I don't know, that looks like it might be a proportional relationship. Then it says the volume is a function of 36 times the height of the prism. That only works if your volume is 36. As soon as you change, if the area of the base is 36. As soon as you change that, then it's going to change whatever. But I don't know, that kind of looks like a proportional relationship to me. Okay, some rules. The volume of a solid is always a number greater than 0. You can't have negative volume. The volume of a unit cube is by definition 1 cubic unit. If two solids are identical, then their volumes are equal. If two solids have their boundaries in common, then their total volume can be calculated by adding the individual volumes together, which we're going to take a look at in a little bit. Okay, so any questions? As always, bring them to class. Hopefully this was a nice review for you. I hope.